Good morning, welcome back for the lecture series Stoichiometry lessons 8. Today we will see the oxidation numbers. See, oxidation numbers are assigned with a set of rules and with one assumption that an electron pair, though it is linked with a covalent bond, belongs to the electronegative element totally. Though it is not correct, for the bookkeeping purpose, it is taken as granted. And there are set of rules. That is, a set of rules are 6. So rule number 1 for oxidation number or oxidation state to be qualified. In elements or atoms, if they are free state, their oxidation number is 0. Example: hydrogen, oxygen, nitrogen, so and so, anything, magnesium, aluminum, whatever it is, their oxidation state or oxidation number is taken as 0. No exemptions in this rule. Rule number 2. If any ions are in free state, their oxidation number is same as what they have the charge. Example: sodium plus, there is plus 1, magnesium plus 2, means it is plus 2 oxidation state or oxidation number, aluminum plus 3 means it is plus 3, iron plus 3, that means it is a plus 3 state. There is no exemption for this also. Similarly, alkalis and other things. Now coming to the oxygen, there are some 3 exemptions, and first we will see. Normally, generally, oxygen will be with oxidation number of 2 is assigned, but there are 3 exemptions. Exemption 1, when it is peroxides, this rule is not applicable. Peroxides are H2O2, and another peroxide is Na2O2. In this case, oxygen is -1. It is not, generally it is -2. In the peroxide case, exemption 2, it is exemptions. In the exemption rule number, in the oxygen itself, is B is superoxides. Here, superoxides are potassium dioxide or rubidium oxide. In this case, it is 1/2. That means it is -1/2, -1/2, because potassium is 1 plus 1, rubidium is also plus 1, 1/2, and then the charge is negative. So oxygen will have, here it is -1, here it is -2 in the case of superoxides. Number 3, when it is mixed with fluorine, compounds are OF2 or O2F2, like these compounds, it will be plus. Here in this case it is +2, here in this case +1. That means there are 3 exemptions for oxygen. Generally it is -2. In the case of peroxides it is -1. In superoxides it will be -1/2. In compounds with the fluorine it will be sometimes +1 or +2. These are the 3 exemptions in the oxygen, where oxidation state concerned. Number 4 rule: hydrogen will be normally +1, but again there is one assumption for metal hydrides, NaH or lithium hydride, like this hydrides, it will be a -1. Hydrogen is -1 will be the charge. But in the case of the lithium hydride, sodium hydride, or even calcium hydride, here also it is -1. This is one exemption. Normally +1, exemptions are -1 in the metal oxide cases. Here 3 exemptions in oxygen case. This first 2, there is no exemption. Then rule number 5, halides. there is no change for fluorine. Because all this simple rule, out of all the rules, what we want to say is electronegativity atom is having minus. That is the first rule, thumb rule. The more the electronegativity, the higher the, or whatever the electronegativity is, the negative oxidation number. So when oxygen is formed a compound with chlorine, bromine, iodine, then their halide, these are halides, chloride, bromide, iodide, halides, oxidation number is +1, not the, like normally -2, -1, but when it is mixed with oxygen, because oxygen electronegativity is more compared to this thing, whereas fluorine is much more than oxygen, right? This is 5. 6, in any compound, the sum of the algebraic sum of the negative and positive charges is equal to 0. Examples, just a simple H2CO3, 0. Actually it is +4, -6, +2. +2 means actually hydrogen +1, 2 are hydrogen atoms +2. Don't get confused. Hydrogen is only 1. There are 2 atoms, so it is +2. Carbon is +4. 3 oxygen atoms -6. Total equal to 0. So all the time it will be in a compound. It will be 0. These are the oxidation numbers, this thing. Now, what is the definition for reducing agent? According to the oxidation number, reduction of a species is the decrease in the oxidation number. Oxidizing agent means a reagent which increases the oxidation number. Similarly, reducing agent, a reagent which lowers the oxidation number is reducing agent or reductant. So now we will see the combination reactions. These reduction reactions are a combination reaction. There are some 4 types combination reactions are there. The combination reactions, one is the combination reaction, second one is decomposition, third one is metal addition, then metal removal of the metal, either there are disproportionate reactions are there. Now we will see the how to ascertain 1 or 2 oxidation numbers. So wherever the exemptions are there, that we will see tomorrow. Wherever a simple one, we will see first. Now in the addition reaction, C plus O2. So what is the first rule for the elements and atoms? It is 0. So carbon is 0, oxygen is 0, the product is CO2. CO2 means +4 and here -4, because 2 to the minus, total it is 0. Rule number 6 also valid, and rule number 1 is also in this same equation. One more example we will see. 3 Mg plus nitrogen gives magnesium nitride, Mg3N2. Here also 0, 0, because the rule number 1 in this compound, magnesium, first nitrogen is to be given as -1, so it is -2, right? Magnesium is, nitrogen is -3, -3 into actually 2, -6, magnesium is +2, +2 into 3, +6, actually +3 into 2. Total it is 0. Both are matching. That is a simple 1 and 6 is. One more we will see the sulfuric acid. In this sulfuric acid, hydrogen is +1, +1 it means +1 into 2. Oxygen is -8, means 4 into -2, -8. So sulfur, if somebody asks what is the oxygen number, means +1 into 2, 8 plus -8 plus 2, it is +6. Oxidation number of sulfur is +6 in this compound. Like this it will go on. So we will see tomorrow further the reactions and the complicated. Just for the simple idea, what is the oxidation state of iodine, Ki3. Remember, potassium is +1. Normally iodine is -1. So now how to say this reaction? Think and keep it.